Grok 4.5, Qwen 3.8, and Kimi K3 all claim they're the model your coding agent should run on. So we put all three through 5 head-to-head tests using nothing but official docs, independent benchmarks, and community-verified numbers. The surprise isn't which one scores highest, it's that Kimi K3's headline 88.3% terminal bench score doesn't hold up when someone else runs it independently, dropping to 80.9%. By the end of this video, you'll know exactly which one deserves a spot in your agent stack and which one is selling you a number it can't back up. If you're running an agent that fires off hundreds of calls a day, the per token price is the difference between a manageable bill and a nasty surprise. Grok 4.5 and Qwen 3.8 are priced identically at $2 per million input tokens and $6 per million output tokens, according to official docs. Kimi K3 charges $3 in and $15 out, which is 2.5 times more expensive on output alone. That gap gets worse once you look at actual task completion cost. Artificial analysis estimates Grok 4.5 costs about 31 cents per task on their intelligence index, while Kimi K3 runs around 94 cents for the same kind of work, roughly 3 times more. Qwen 3.8 doesn't have a published figure here, so I can't score it on this specific number, but its identical per token pricing to Grok suggests it lands somewhere close on raw cost. Part of why Grok pulls ahead is token efficiency, not just sticker price. On SWE Bench Pro, Grok reportedly uses 4.2 times fewer output tokens than a comparable Claude model, which is directional data, but it lines up with an effective cost of around 10 cents per resolved task. That's the kind of efficiency that compounds once you're running this at scale, say 1,000 coding tasks a month. Grok 4.5 takes this test clean. At that volume, Grok lands around $100 total, while Kimi K3 could run 3 times that for similar work. My name is Brian, and I review AI software so you don't have to. Digging through pricing pages and benchmark reports, so the decision is already made by the time you finish watching. Cost doesn't matter if the model can't actually solve the problem, so let's look at raw coding ability. One of the biggest problems I run into when using AI agents is turning their output into YouTube content I can actually use to market my product. That's why this video is sponsored by Subscriber, a tool that helps business owners connect their AI agents to YouTube and market their products without spending 10 hours every week creating content. You can connect Claude or ChatGPT directly to Subscriber. It then analyzes your business, website, and YouTube channel to help you create SEO-optimized video ideas, scripts, thumbnails, and even complete videos that actually match your brand. What I like most is that every week, Subscriber gives me a list of high-potential video ideas I can immediately execute, and it can even help edit videos for me, with or without my face, including videos like the one you're watching right now. It's easy to get started, and you can try Subscriber for free using the link in the description below. Now back to the video. On SWE Bench Verified, which tests real GitHub issue resolution, Kimi K3 scores 93.4%, a top 3 global result, ahead of Grok's 86.6% and Qwen's 80.4%. On Terminal Bench 2.1, which measures agentic work inside a terminal, Kimi K3 again leads at 88.3%, with Qwen close behind at 86.6% and Grok trailing at 83.3%. Kimi K3 also sets a new mark on SWE Marathon, a long horizon coding benchmark, at 42.0%, well ahead of Grok's 29.0%. Qwen doesn't have a published figure there. On Frontier SWI, Kimi K3 leads at 81.2% against Qwen's 73.5%, with no published number for Grok. Kimi K3 is also the #1 model on the front-end code arena at a 1679 LO, making it a genuine front-end specialist. But here's the caveat that matters more than any of those wins. Community-reported testing put Kimi K3's terminal bench score at 80.9%, nearly 8 points below the vendor's claimed 88.3%. That gap is worth remembering every time Kimi K3's benchmark numbers get repeated as fact. Even accounting for that, Kimi K3 still wins this test outright on the strength of SWE Bench Verified and SWE Marathon, both of which show a real, unambiguous lead. Qwen 3.8 is a strong all-rounder here too, consistently second place, while Grok trails the pack on every raw coding number in this section. That's not a small rounding difference. A model that codes well but takes forever to respond breaks the feel of working inside a real agent loop. On artificial analysis's independent throughput measurement, Grok 4.5 hits 61.0 tokens per second, Qwen 3.8 comes in at 51.5, and Kimi K3 trails at just 32.0. That's nearly double the speed gap between Grok and Kimi. Other sources back this up. OpenRouter measured Grok in the 47 to 52 tokens per second range, and OrcaRouter clocked it as high as 84 tokens per second, with Kimi K3 landing somewhere between 37 and 62, depending on the load. One community comment I found put it bluntly: Grok 4.5 just destroys it on speed, and the measured data agrees with that take. Time to first token tells a similar story. Grok's TTFT ranges from 1.8 to 17 seconds, depending on reasoning depth, while Kimi K3 sits at a more consistent 2.8 to 3.0 seconds. That constant heavy thinking mode is a direct trade-off for raw throughput, and it's why Kimi K3 is the slowest of the three, by a wide margin on actual token generation. Grok 4.5 wins this test clearly. That's actually a point in Kimi's favor for latency, but Kimi's core problem is that its reasoning is always on at max effort, with no way to dial it down. Stick with me, because the last 4 tests are where this decision actually flips. This is where the story flips into a genuine tie. Grok 4.5 tops out at a 500k token context window, while both Qwen 3.8 and Kimi K3 offer a full 1 million tokens, double Grok's ceiling. If you're feeding an agent an entire large codebase in one pass, that difference is real and it matters. Where Grok pulls back some ground is reasoning control. Grok and Qwen both let you configure reasoning effort from low to high, so you can dial down cost and latency on simple tasks. Kimi K3's reasoning is always on at maximum with no way to disable it, which is a real handicap for anything that doesn't need deep thinking. On maximum output, all 3 support roughly 131k tokens per response, but Kimi K3 can be configured up to a full 1 million tokens in a single generation, which edges it ahead on that specific metric. Because Qwen and Kimi tie on the headline context number, the biggest number in this whole comparison, I'm calling context and output limits a tie between those two, with Grok clearly behind on raw window size but ahead on flexibility. The best model in the world doesn't matter if you can't run it where you need to. Qwen 3.8 and Kimi K3 are both open weight, meaning you can self-host, fine-tune, and fully control your data. Qwen ships under an Apache 2.0 license, the most permissive of the 3. Kimi K3 has a custom MIT-style license that includes a revenue-based clause, something worth knowing before you scale a product on top of it. Grok 4.5 stays fully closed and proprietary, available only through xAI's API or partner clouds. Modality tells a similar story. Qwen and Kimi both natively support image and video input, while Grok is limited to text and image, no video. On the ecosystem side, Qwen has day 1 support across NVIDIA, DigitalOcean, and Cerebras, and Kimi K3 has broad backing from Modal, Together, Fireworks, and VLLM. Grok's ecosystem is real but narrower, built around Cursor and OpenRouter. Qwen 3.8 wins this test outright. It offers the openness and modality range of Kimi K3 without the murky licensing terms, all while matching Grok on price. Grok 4.5 wins on cost, taking the cheapest per task price at 31 cents against Kimi's 94 cents, and it's the fastest of the 3 at 61 tokens per second on independent testing. It's also the default model inside Cursor, which makes it a zero-friction pick for a lot of developers already in that workflow. Qwen 3.8 wins deployment and modality, matching Grok's low pricing while offering open weights, a permissive Apache 2.0 license, a full 1 million token context window, and native video support that Grok doesn't have. Kimi K3 wins the raw coding benchmarks, topping SWE Bench verified at 93.4%, and setting a new mark on SWE Marathon at 42.0%, plus the #1 spot on the front-end code arena. But it's the slowest model here at 32 tokens per second, the most expensive at $3 in and 15 out, and its headline terminal bench score doesn't fully survive independent verification. Grok 4.5 is the default pick here, and it comes down to one thing. For the everyday coding workflow most developers actually run, speed and cost beat a few extra benchmark points every time. It's the cheapest model per task, the fastest by a wide margin, and it's already sitting inside Cursor for a huge chunk of working developers. If you need the absolute best raw benchmark performance or a full 1 million token context for a massive codebase, and speed is genuinely secondary, Kimi K3 is the more powerful pick. Just know you're paying roughly 3 times more and waiting longer for it. If open weights and licensing flexibility matter more than either of those things, Qwen 3.8 is your lane since it matches Grok on price while giving you the self-hosting option Grok doesn't offer at all. The one thing marketing won't tell you is that Kimi K3's blazing fast benchmark scores don't all check out. Moonshot claims 88.3% on Terminal Bench 2.1, but an independent run put that number at 80.9%, nearly 8 points lower. That's the exact kind of gap that decides whether a benchmark screenshot is telling you the truth or just the story the vendor wants told. If you want to see how these three stack up specifically for front-end heavy development, where Kimi K3's front-end code arena lead actually gets tested, that's the comparison worth watching next.